well, 2 NFLs. Shares Stadium is going to be 50%. I should probably.
All right, so this week, I think primarily we'll just be kind of going over a couple more papers, so we're getting some refresher on like there's a lot of linear regression, like interpretation, mentioned things like p-values, just like you want to measure the relationship between or have a certain question, what variables we look for. I might be going over a little bit of the little bit more of homework for kind of throughout the week. And I'll get that answer key posted up this afternoon. But also I'll probably leave a little bit of time at the end of every day this week. So I kind of think I mentioned this last week, I'm not using the eye clickers anymore. So I'll get hopefully today, if not today, for sure on Tuesday, uploaded you what your eye clicker score is in the class with your 3 lowest drops, so you'll kind of know where you're at going into the final. I'll also get like a figure out your grade tool, and I'll kind of show you how to play around with that on Wednesday. The only thing left that kind of has to be built in there is that 5th homework, which I said I'll drop the lowest, so it's kind of optional. If you've got a homework grade you want to replace, you can do that 5th one. So if you've done on the first 4 and you're happy, like you can kind of use that tool to start playing around with, well, what do I need on the project and the final to kind of get certain grades in this class, right? Other than that, are there any questions from me before we jump into things here? Like I said, I'll probably try to leave a little bit, kind of get out a little bit early. If you guys have questions over kind of your projects, I'll kind of go around and answer those. A couple people kind of showed up Friday, got a little bit of help there. So I had this paper that I thought was kind of interesting that I wanted to bring in to kind of show like we could not necessarily look at things like just in a sporting context, right? Like this could be anything kind of related to sport. So this isn't like any one sport, but this is just, does sports participation kind of impact crime, right? So what might the thought process be here? I mean, if I'm looking at adolescent children, I don't know, I say adolescent. So if I have like teenagers, right, what might be something I think why sports participation might be linked to crime rates in an area? Yeah,
Be like a lack of sports engagement is higher crime, or
yeah, lack of sports engagement. So we think about what does sports kind of do? They give these kids something to do as opposed to just wandering around and being up to no good, right? This is the idea of like a boys and girls club. That's the fundamental idea is like there's no after school programs. You can kind of use sports as kind of an after school program. Like these, children tend to get into more trouble, right? So that's the general idea behind this paper. So let's scroll down. They've got a nice regression equation here. There it is. So what they're going to do is they don't have like individual level data, but they have, I believe it is, I forget how it is. I'm not familiar with the UK. It's kind of like city level, but it's like they've got some measure of like regional crime rates, right? So it might not just be a city. It might be like, a metro area or something a little bit bigger, but it's generally thinking about this as like city crime rates. And then what was the participation rate of kind of young males, like this young male rate? What was the participation rate of individuals in sport? And then I think they broke this out specifically into, oh no, this was just the percent of kind of young males, right? It's kind of control for maybe this percent sports participation. Maybe we should control for like, well, we know that males commit crimes, adolescent males commit crimes at higher levels, and so we want to control for that as well, right? So we've got, the average income in the area, the unemployment rate in the area, which are also very good predictors of crime. So remember, whenever we interpret these results, and for the sake of what we're doing, they put the natural log and everything, we're going to ignore that. I'll mention at the very end what that would do. But just think about these as like dropping this L in is what's the impact, how can we predict crime rates from sports participation in the region, unemployment rate, average income, and kind of the percent male, or percent young male if we're looking at the adolescents. So, one way we would interpret this coefficient, if I think about sports participation being measured in, let's say, all this is just measured in percentages, right? Becomes a little bit easier, right? So if I've got sports participation, and it's kind of the percent, right? So for every 1% increase in sports participation, right, it's my units, we would predict that whatever the slope coefficient is on that variable, that our y variable goes up or down by whatever that amount is. So if our kind of idea, like, you know, these after-school programs or sports participation, kind of keeping kids out of doing, you know, out of situations where they're going to do dumb things and commit crimes, what would we expect that coefficient to be? For every 1% increase in sports participation from our adolescents, we expect crime rates to go down, right? Or a negative coefficient, right? Now, one nice thing with these natural logs, and I'm not going to give you an example like this on the exam, I would kind of keep everything like we looked at, like these linear relationships, but it's kind of a nice thing because like crime rates, unemployment, like income levels, those aren't in terms of percentages, right? Those like income we measure in dollars, crime rates, it's like the number of crimes per 100,000. So when you take natural logs, it gives you this really nice interpretation. So I'll make it this one kind of just basic. And like I said, I might show you, and I'll try to mention if I, you know, some of the stuff I'll show you this week will be helpful in understanding the more basic kind of regression analysis, but I may not push you quite this far. I'm not going to push you quite this far in the exam to use these natural logs. So I guess technically crime rate. And then I said sports participation, right? So I think that the actual variable they have is sports participation isn't percentage, but it's the number of individuals who are involved, right, in sport. So when I take the natural log of something, if I take the natural log of both my independent and my dependent variable, right? The interpretation of this coefficient, instead of being a 1 unit change in my x variable, causes my predicted y to change by whatever that slope coefficient is, units, right? I actually become a 1% increase in my x variable, causes my y variable to change by whatever that coefficient is percent as well. So this kind of captures that, you know, we're not always just concerned in how many units. So like increases in income, the same increase in income can be very different depending on where income starts, right? So let's say I see a $10,000 increase in my income. My original income was $40,000. Going from 40 to 50, that's like a 25% increase from my old income. That's a pretty sizable effect. That might have a huge impact on things, you know, I do, right? Like whether or not I can own a home, or whether, you know, all these other, you know, maybe variables on a. If I go from making $200,000 to 210,000, same unit increase, but that's a much smaller increase in the type of like lifestyle increase I can get, right? Going from 200 to 210, that's only what, a 5% increase in income. That's going to have a lot lower of an effect, right? So we might want to, instead of using the units, we want to say, well, what's the percent change in that increase for that person's income? Here, that's what we're going to do here. What was the percent change in sports participation, and how did that impact the percent change in crime rates? So we can kind of capture these factors. There might not be, you know, the units don't always capture that our marginal kind of effects are decreasing, right, as we move along, you know, a variable size. So in this case, higher levels of income, the impact of an additional $10,000, it's going to be decreasing, right? It's a lot more valuable when I don't have as much money to have an additional 10,000 as opposed to when I'm like a millionaire. So that's what they're doing there. But for all intents and purposes, we're just thinking about, we're trying to figure out what's the effect of that sports participation on crime rates, holding constant these other things, right? So we'll go down here, because I think they threw all their tables at the end. And they've got a bunch of different models we don't have to measure too much about, or kind of worry too much about. They just kind of start out with a very naive model, right? Where they've only included sports participation on the right-hand side there. They then start adding in additional controls like income and unemployment, kind of what percent of the population, the adolescent population was with males. And you kind of see like the coefficient is changed a little bit by adding in these additional controls, right? We want to start interpreting these different variables, and for the sake of our interpretation, we'll think of like we're not using natural logs here, because that's what I would expect you to do on the museum. So for every dollar increase in income, we would expect crime rates, and I think it was measured in per 100,000 people, to decrease by about 0.18, right? Holding everything else constant. And if I want to interpret the unemployment rate variable, well, this is literally measured in percentages. So if my unemployment rate goes up by 1%, we would expect that crime rate to decrease by 0.221 per 100,000, right? So it's just a 1 unit change in my X variable causes my Y variable to change by whatever that coefficient is units for my predicted Y value. What they then do is kind of break this up a little bit, where you've got the unemployment rate. I don't know why they dropped in. Oh, I see. So they did the income rate times participation, right? So I'm not going to use anything like that on the exam, so we can kind of ignore this for right now. We'll just kind of focus on this model 3. Okay. So it looks like here they found, pretty good evidence that if you can get a higher proportion or a higher number of participants in sports, right, youth in sports, that actually has a decrease in crime rates in the region, right? Like I said, I forget exactly how they did this. Was like counties or cities. I think it was a little bit smaller than counties. Okay. Now, another thing that we'll kind of start focusing on a little bit more is, I'll try to emphasize a little more, I should say, is this R squared. So remember, this R squared is telling us kind of how good our predictions are going to be. We want R squared close to 1 as possible, right? Because that would tell us that we're explaining the proportion of the variation in our Y variable we can explain with all of our X variables is all of it, a proportion of 1, 100%. So here we've got an R squared of 0.338, so an overall R squared. Won't kind of make you do anything with the word in between. So 0.338 means these 3 variables I've included, these 3 X or right-hand side variables, explain about 39% of the variation, or proportion of variation they explain is 0.39. So that's pretty good. We're still not explaining 60%. So we want to be a little bit cautious when looking at these coefficients, right? But these are all good things as you're kind of finalizing your project. Like, I'm expecting you mention this about your own regressions. What was the R squared? How accurate are your predictions going to be? What proportion of variation can you explain? Interpreting the coefficients on your different control variables. Now, when it comes to the project, you don't have to do every single variable, right? Mainly, I'm going to be focused on interpreting those variables that are of interest to answer your question. So like in this example, really making sure that you interpret the sports participation, right? If the whole question is how does sports participation impact crime rates? And yes, part of the discussion will be, well, we know that if we don't include these other important variables, our coefficients will be biased, right? So I want to make sure that I mention, I do include these other additional control variables, but really you want to focus on the interpretation of the slope of that variable that answers your question. Okay. And then not only do you want to say, well, before I go back here, not only do you want to make the interpretation of what that coefficient is telling you, you want to also say, is it, what levels can I say this is a significant relationship? So what levels can I say that coefficient between sports participation and crime rates is significant? Well, we make our rejection decisions based on if the p-value is less than alpha. Our kind of benchmark alpha levels, 0.1, 0.05, 0.01, kind of corresponding to 10, 5, and 1% significance levels. So we said, what do I always start out assuming about these slopes? We always start out assuming that the relationship between our X and our Y variable is, 0, right? So if I can reject this, I'm saying that there's a significant relationship. I'm rejecting that there's no relationship. So if I looked here, well, it's easy when I'm looking at this output because they gave me stars and let me know, right? But if they didn't, right, and they gave me instead this p-value, right? Or actually, this is I think they give you your standard answer. Yeah. So here we don't have our p-values, right? In your Excel output, you'll have the p-values in the column next to your estimates. So if I'm looking at this, this is going to be like what? A test statistic of 3.3. You don't have to worry about that. I'm not going to ask you to calculate test statistics, but this is like 3.3. which basically means your p-value is going to be something like 0.005, right? It's gonna be really small, right? So in this example, like I have a really low p-value, that's gonna be less than every one of my benchmark alphas. I can reject there's no relationship at every single level of significance. So that's why they don't show you the p-value here. All they're showing you is, yeah, that we can reject 3 stars, 90, 95, 99% confidence, or 10, 5, 1% significance. Now, when you actually have the p-values, you're going to have to make that decision yourself, right? Looking at that Excel output that you see and saying, does that p-value, is that p-value less than alpha, right? And compared to these 3 kind of benchmark alphas. So could be some discussion of your R squared on your project, right? For your regression. Definitely the interpretation of your variable of interest. If you want to interpret some of the other control variables you use, that's fine, right? In this case, it's interesting to see like, oh yeah, this kind of makes sense. When income goes up, prime rates go down. When unemployment rate goes up, prime rates go up, right? So it might be worth mentioning some of these other controls. But you really want to focus on kind of the interpretation of that variable that's going to answer your question. Right? And for some of you, I talked a little bit, maybe you've got a question and, the data is not going to be perfect for many of you, right? So maybe you want to run 1 or 2 regressions, right? Where you change the dependent variable a little bit. So, maybe one measure you had of wins or success was wins. Another variable you had was, did you make it in the playoffs or not? Run 2 regressions, right? Interpret the coefficient, and maybe you were thinking about, well, how do expenditures impact those things? So interpret how do expenditures on your team impact the expected wins, and then from the second regression, how does the expenditures impact the predicted kind of probability of making it into the playoff set, right? That 1-0 playoff area. So it doesn't have to be one regression, you can kind of include several, but I need to see at least one, right? Any questions on anything up to this point? Clear? Okay. So we go down here. I don't think there's anything else in this paper I really want to go over. The other one is betting market outcomes and TV viewership. So this is going to go back a ways. I'm going to try to tie this into the labor market as well. Okay. So this paper kind of goes back to this idea of, if we see more uncertain events, are people more likely to want to watch that game, right? The idea that if we don't know who the outcome or the winner is going to be, maybe it's more likely if, say that differently. If we know who the winner is going to be, we're less likely to watch it, right? If it's going to be a really, Alabama football versus Ball State, I kind of already know the outcome, right? So we'll scroll down. They got a pretty nice little regression here. Once again, let's just ignore the natural log here. We'll just think of this rating as like the units of this rating variable is just like 0 to 100, right? Was the TV was the rating on the TV viewership kind of higher or lower, right? Going from 0 to 100. So they've got all of these control variables. Like this is a lot of different control variables. The main one they're going to focus on is, well, what's a good measure of how lopsided or unbalanced the game is, right? So come down here. So we're thinking about, how is that TV kind of viewership rating? How is that impacted by the point line? I forget how they say it. I'll have to go back and look, but the point spread of that game, right? So if you think about this, if I've got point spreads of -7, -8, the larger the negative value, that means that that team is favored to win by more. So the kind of larger in magnitude our point spread goes, the actual more lopsided the game's going to be, right? They're predicting that this team's going to win by a lot of points. On the flip side, if I had larger positive values, that's also telling me the game's going to be more lopsided, right? That this team is expected to lose by kind of 9 points. That's kind of the 50-50 cutoff, right? So what this paper does is say that, well, look, we don't care what direction, we don't care who's favored, who's not. All we care about is what's the absolute size of these point spreads, right? Because the problem, if you keep negative, well, like larger negative values actually means it's going down. So the interpretation is kind of, so we're just going to say, is the magnitude or the absolute value of that point spread higher? If it is, that's telling us these are more lopsided games. So under the uncertainty hypothesis, if the point spread goes up by 1 point, right, 1 unit in absolute terms, what would we expect the sign of this coefficient to be? The point spread goes up by 1. That means the game is becoming more lopsided or more certain. So what we expect to happen to TV ratings? Yeah, they'd go down. So the predicted change would be negative, right? That coefficient would be negative. So when it comes to like the exam, if you're looking at some of those practice problems I put up, I might take something that we've talked about or a kind of basic like concept, like the uncertainty hypothesis, which is, and then say, what do you expect the sign of this coefficient? I'm not going to ask you for the exact value, right? You don't know that replicant did it, but you should be able to kind of have an inclination about what the sign should be if you understand kind of the underlying economic principle behind what we're trying to run a regression on, right? That we expect increased uncertainty, right, would mean that people are more likely to watch. Well, here, it's just phrased the opposite, right? I should have said, more uncertainty. So more certainty would then predict that you see, a drop in TV viewership, attendance, things like that. Any questions on this so far? Shouldn't be too bad. So we'll look at kind of what they have here. I believe that's the where is it? Can I find it? Closing line, combine. I think that's just this variable here, right? The kind of covered point differential here. Okay. Now they even control for things like, just because the game is going to be lopsided, if the over under was like really high and you think there's going to be a lot of points scored, well, maybe that drives up, even if I think it's going to be, I don't know, a 14-point game, but I expect the combined points to be really high, it might be an exciting game to watch. So they control for things like that. They control for, was it a national TV game? Because that's going to impact the TV viewership rating, day of the week, start time, all of these different, were there other things going on at the same time, like postseason and other sports? So what, regular season NFL, postseason NFL. So they try to control for all these things. And I believe, if I remember right, is this NBA data? Yeah, so they're just specifically looking at NBA TV viewership, okay? So we'll go down here. And this is just, oh wait, here we go. So here they're just using that kind of TV viewership rating. And they're looking at this covered, oh wait, sorry. Let me make sure I'm remembering these variables correctly. Let's go up to where they define them so I don't say this incorrectly. So I want to find, so the closing line, okay, I did incorrectly identify this, sorry. The cover differential is not, this closing line is what measured the point spread. I don't know why they said closing line instead of point spread or cover spread, but that closing line kind of represents that absolute value that we were thinking about, right? So we would expect beta 1 here to be negative, right? As that line goes up, the point differential gets higher, we expect TV viewership to be lower. So they did kind of an interesting thing, which is they also tried to account for, well, what was the actual outcome of the game and relative to what that line was, right? So even if like the line was +9, well, TV viewership might be really good if it's a really close game and a lot of people tune in at halftime, right? So this is trying to kind of capture like the gap between the actual line that was set and, sorry, the line that was set and what the actual difference was at the end of the game, right? So this is going to pick up for games that might have gotten excited that weren't expected to be at the very beginning. So this is really kind of the fan anticipation of the uncertainty, the impact on TV viewership ratings. So we'll go down there again to their table. And sure enough, that closing line estimate, we find it to be negative. And here we've got 2 stars, right? So that's telling us that it's significant at the 90-95% confidence level or 10 and 5% significance level. So for every additional point that line goes up, right, that TV viewership rating fell by 0.005, right? So like I said, if you want to think about this TV viewership rating measured from 0 to 100, If I go up by 2 points, well, if this is the effect of 1 point, if I go up by 2 points, it's making it fall by about 0.01. So you kind of scale that effect if you really wanted to. So for some of you in your project, that might make more sense too, right? If I'm looking at this effect and it's pretty small, and I'm like, well, you know, a lot of times I can see the point spread go up by a whole touchdown. This is NBA, so I guess this doesn't, but maybe 5 points, right? Well, if I know the effect of 1 more point, the effect of 5 more points is just take that coefficient for the effect of 1 point, and multiply whatever you want to scale it up to. So a lot of times this makes more sense if you're dealing with like expenditure data. I mean, if I spend $1 more, that effect on everything is probably going to be really small, right? So you might want to scale that up to, well, what if I spend, you know, depending on the example, like $1 million extra on your payroll in any professional sport is not unrealistic, right? So I might want to scale that effect up. All I do is have to multiply that by whatever increase I'm interested in. Okay. Questions on that idea before we keep moving here? Okay. Where else do I want to go? So I'm gonna go down here a little bit. So there's another one that's kind of is this it? Yeah, we'll just focus on this one because I don't want to complicate it too much. I don't want to give you anything that I wouldn't necessarily give you on the exam. So another one to kind of just point like some things that you would expect. So this is where like sometimes when you have control variables, you want to control for that, like there's not something weird going to the data, like the other variables are what you would expect, right? So here, this other variable, which is combined WP, is the combined winning percentage of the 2 teams. So if the combined winning percentage goes up by 1 unit here, we would expect that the TV viewership rating goes up by 0.08. Well, that makes sense. If we have higher quality teams, probably more likely people want to watch them play, right? Excuse me. What's kind of interesting is, I'll point this one out. So I've gotten this question from people about their projects, and a lot of times you have this data, so it's a good additional control to use. So I've got this year variable, right? So if I'm including as a control the year, what is this coefficient telling me? What's a 1 unit change? We measure years in years, right? So for every additional year that passes, here's the predicted change in TV viewership rating. So this was like what, 0.081, and it was highly significant. So this is telling us what? That over time for the NBA, TV views have went up, right? This is capturing kind of like this linear trend that's occurring over time, right? So this is really a good control to use because, you know, TV viewership ratings, if my sport is becoming more popular, then every single year that passes, I should expect to see TV views go up, right? So I want to account for the like this trend that my sport is moving. Could be negative, right? If I ran this for Major League Baseball, I imagine this might be a negative coefficient, right? Depending on what years I look like, but if I'm looking at the last 20 years, probably is a negative time trend, right? And I want to be able to control for that, okay? Now some of you in econometrics might be saying that's not appropriate. Do any of you have econometrics or have taken it? What should I probably do? You guys talked about this?
Like time series data?
So you can look at time series data. What's another way instead of, so if I have years, that means that I think there's a linear time trend. So what's another thing I could do to make it not be linear? Maybe like some years, like there's no even real rhyme or reason to why demand is higher or lower, or maybe things vary in a non-systematic way. If I really wanted to, I'm not saying any of you have to do this for your project. If you want to use year as a control, I would suggest using it just to capture this time trend. Just assume it's linear. That's okay for the sake of this class. What we might want to do is something where if I think that different years are going to have different impacts, but I don't know what years those are going to be, right? There might be something that happened like COVID one year that's going to greatly decrease, or maybe actually during COVID, my imagination would be TV views might have actually went up, right? So what I'll do is I'll start to say, okay, 1 0 variable for was the data from the year 1997 or not? 1-0 variable from, was it from 1998 or not? And basically include what we would call these year fixed effects, right? Now, this allows for the effect on the TV rating to just change every single year by different amounts, right? So just mentioning that because I've heard this talked about in the classes, like this is probably the more appropriate thing to do. But for the sake of like your projects, a linear time trend is more than adequate. Okay. Does that make sense why we would do that instead? Kind of allows for, you know, this 1 year, maybe the increase is 0.08, the next year, maybe it's negative 0.02, right? The next year it's 0.05 positive, you know, et cetera, et cetera. I think if there's anything else, you know, we kind of look at these other ones, you're like, oh, later start times, right? I think this is relative to like a 5 p.m. start, 5 p.m. start time, so a lower start time starts to increase kind of the TV viewership rating. Start to get too late, though, well, the effect isn't quite as large, right? I imagine if you know you had more variation in start time, I would like this would kind of be cool to do with like college data because you got some of these games on the West Coast, like Hawaii, their games start at like I think some start like 11 or 12 Eastern time, right? So like you've got a lot more variation in kind of when you would have start times, you can kind of pick up a similar thing. Also, kind of notice if there's an NFL game on at the same time, whether or not it's regular season or postseason, what's happening to TV viewership rating? So this is just 1-0 variables. So if there's an NFL game on at the same time as this game, TV viewership rating goes down by a pretty large amount, right? The postseason game goes even down by even more. So what is this telling me about NBA and NFL games? We would call them
Substitutes.
Yeah, right. This would be evidence that there's substitutability between sports, right? That can only do one thing with your, I mean, I guess technically you could watch multiple games at the same time. Most people probably focus on one. And so that there is some substitutability even across sports. I can be a fan of multiple sports on average, right? Right, there is some substitutability. Some people will stop watching NBA games if there's an NFL game on. Which is also another thing. I'm just trying to relate to stuff we talked about all semester. So this would also be evidence that when we talk about having monopoly power, it really depends on what I'm talking about. I have monopoly power. Maybe this is the only NBA game on that day, but I don't have monopoly power in just professional sports games, right? That if there's increased competition, I will see a drop in my TV viewership. If there's anything else overly interesting I want to say from these results, but any questions on that? So I wanted to relate this. So if we found that there is this negative impact, right? So if I have a more unbalanced game, right, that point spread is higher, I see a decrease in TV viewership, right? Why would players care about this, right? Or we can even think about the other one, like if there's an NFL game on at the same time, there's a negative impact on TV viewership. What's that going to do to the contracts of our players, right? So let's think about, I have this starting scenario. I'm looking at a player of a certain quality and the demand coming from a team, right? If all of a sudden, right, I'm thinking about, you know, these games on average are becoming more uncertain. The point spreads are starting to get larger in the NBA. What's going to happen to my demand curve for labor? Well, my demand curve for labor is based off the marginal revenue per win times whatever the quality of that player is. So if I'm seeing an increase in the average point spread, right? Games are becoming more uncertain. TV viewership goes down. What's happening to my marginal revenue per win? Well, if TV viewership goes down, what's going to be true about the deals the NBA makes when they're selling off these packages of games? They make less money, right? So if this negatively impacts the demand for the sport that across every team, right, to have lower TV viewership ratings, what would we expect to happen? Equilibrium wages, we would expect them to decrease, right? Also, if I've got, you know, okay, before I'm going, any questions on that? thought about this before as well. In the context of team sports, it's a little bit different. Like my contracts sometimes are several years, you know. I can't have the ability to make this decision, but it's a very similar idea. Okay. So let's say instead I'm thinking about like a fighter, right? A UFC fighter, right? And let's say that just like with basketball and football, let's say if I did this same regression and I'm looking at UFC TV viewerships, but instead of controlling for the NFL, I control for, is there a boxing pay-per-view on at the same time, right? So I was thinking about this last weekend actually, because it wasn't a UFC pay-per-view, but they had an event, and at the same time they had, or at least there was some crossover potentially in, there's a big boxing match, right? I forget it's like Garcia and I don't follow boxing well, but anyways, there was a big boxing match, right? And so if there's any substitutability between those two things, if I'm fighting on that night, what can I expect if I'm a UFC fighter to happen to my wages? There's going to be less tier review. There's going to be less demand. The ads are going to sell for less money. The UFC is going to be willing to pay me less, right? And not only is the UFC going to be willing to pay me less, what happens with the UFC if I'm employed by them, I'm under contract, even if I'm making deal by deal fights? Like this is the only professional league. This is kind of has monopoly power, right? They're going to have, they're going to be the only one demanding labor. So they're going to have a twice a seat marginal expenditure curve. So you actually aren't going to get this wage. You're going to get something a little bit lower, right? Because they have monopoly power. You want to fight, you know, you could argue that maybe there's a competing league of Bellator, but like if you're comparing the amount of money you can make across the two, it's basically a monopoly, right? There's no competition in the sense that no one has as high of a demand curve as the UFC. But, you know, so if they come to you and they're like, yeah, we want to put you on this card, you're like, well, I'd much rather be on the next pay-per-view, right? I know the demand curve for that's going to be higher when there isn't this competing boxing match going on as well. Instead, they look at you and say, well, look, you can either accept this lower wage, right? Or we're not putting you on that card, right? They have some monopoly power over you, right? If the fighters had a little more power, maybe there is a little more bargaining that goes on, right? We could kind of factor in like thinking about a union, right? And so we kind of talked about those contract zones, and then maybe we do see some kind of bargaining back and forth. But I don't, you know, to my knowledge, I think they're actually considered independent contractors. They haven't unionized, which, you know, for the fighters, it would be good if they did, right? But I'll make one more point on that because it's not completely accurate. So let's say they did unionize, okay? And oops, I should have drawn my X and Y axis first, right? So let's say they did unionize, right? One thing that's kind of interesting, let's say you went out, this is your average demand across all fighters, right? So, and I'm going to make an extreme point. This wouldn't be exactly how it works, but it's still useful enough to think about the implications. If this is the average quality fighter and the union is just trying to bargain for contracts for that average fighter, right? Then the union power means there's only one supplier. It's like a monopoly. So they have a twice as steep marginal revenue curve. Let's say there's no monopoly power, just to simplify it. They could get away, this monopoly, with saying, hey, UFC, if you want to have any fighters, you got to have someone from our union. So we have all the power now, right? So we can get a higher wage than we would have even in equilibrium, right? Now, the potential problem with this is if I think about, all right, I'm earning this higher wage, like everybody's earning this higher wage, but if that deal is made for every fighter and I'm no longer able to make my own individual deals, what happens if I was a really high quality fighter? Well, if I was able to make my deals outside of the union, well, I guess however you want to compare this, the wage of the high quality fighter would be greater than that average wage that the monopoly is bargaining, right? So this is a problem in the sense of like, yeah, all of your high quality workers, all your high quality fighters aren't going to want to join that union, right? if the union's only making a deal kind of on average, well, they're gonna be getting screwed. Who's everybody who wants to be involved with the union? What if I had a really low quality fighter? Well, now if I'm just basing off that wage that we're negotiating with the UFC based off of the average quality, it's gonna benefit lower quality players or lower quality players. Now, that's why when we look at actual unions, like you want to say like the auto workers union or something like that, they recognize this, although they don't measure. So then they bargain for like different wages at different skill levels, right? They're not going to just look at everyone overall and say, here's the wage that we want to negotiate with, you know, GM or whatever it is, or the union would say like, we don't want to just negotiate one wage for workers, but maybe you start to use experience. So we see this in kind of the automotive, like you've got 5 years of experience, here's kind of the wage scale that the union has bargained for. And then usually if you have 5 to 10, well, they're assuming you're now higher skill, you've been on the job more, you've been able to kind of show up to work, not get fired. When you're higher quality, you get another pay, right? We've bargained for wages that are higher for that because we believe you're higher quality now, right? Same kind of idea could be done in the UFC, like maybe instead of, now experience isn't a perfect measure, right? But maybe in the UFC, they use something like, well, what's the number of fights you've had? You've had this many fights. Here's kind of the agreed upon wage for fighters who have like between 5 and 10 fights, right? Here's the agreed upon wage for fighters who have 10, because we're assuming the more fights you get, you must be getting more fights in the UFC because you're a higher quality fighter, right? So you could unionize, and then it's not just that you're making one wage, you're actually bargaining for different wages of different quality fighters, right? Now, what might be a better way to do that than using the number of fights? Will be a better measure of quality of fighter, not just the number of fights, but
If they're on the main card.
on the main card, right? The number of times I've shown up on the main card, maybe that bumps up my wage from the company by a certain amount. Another good measure of quality might just be, not that I did fight, but
Your ranking.
my ranking, did I win? Right, like my winning percentage, but that could all be something the union could argue for, right? They could say, look, for fighters who have a win percentage between 50 and 60%, here's what we want to agree upon the wage, right? Because if I'm using some measure of quality, I'm not just having to base this wage off of the average quality worker, I can kind of base it off of closer to what that actual fighter's actual quality is. So if they were making the deal themselves, they would still get a similar deal to what the union has bargained for, except with the union power, they won't be getting this wage anymore, they'll be getting slightly higher wage, right? So that's one way you could alleviate that concern. I don't know, I've thought about this for a while, but the real problem is, unless you have a really good system that you can sell your high quality fighters on, they don't join your union. And if you don't have the highest quality fighters in your union, you don't have a lot of bargaining power, right? It has to be that the only employees that you could get are from that union. So unless you can get complete buy-in, you don't really have monopoly power in the labor market as a union. Any questions on that? Kind of going back to some like older topics that you might kind of see pop up just to kind of refresh our memory on some of them. Other questions on this? Otherwise, I'll probably let us get out of here. If you have some questions on your project, I'll hang around for a little bit, try to answer some of those. I got to take off by 1, but I'll hang around for a little bit here. Okay. So we'll do a similar thing on Wednesday. Probably go through another paper, maybe a couple more models. I'll probably focus a little bit more on some of the questions that were on homework 4. You could think of this week as just review, but just kind of reviewing concepts that are definitely going to show up on that final. I'll also mention a little more of the logistics of the final. I don't know if I mentioned this off the top today, but just so that I get it out there, our final is Thursday. Oh, no, I believe it's Wednesday at noon, if I'm remembering my classes correctly. Oh, where did I have it? I wanted to mention it before I let everyone out of here today. Wednesday at noon. There it goes. I did remember right. All right. So it'll just be an in-class exam, a little bit longer than 2 hours. It looks similar to that take home. It's just that you have all those materials available to you. I think I'll practice questions are a pretty good reflection of the kind of questions you can expect to see. Small batch of multiple choice, short answer portion that looks similar to the homeworks. Other than that, if you guys have any questions, feel free to email me, kind of stop by during office hours this week. And I'll see you guys on Wednesday.